Hello and welcome back. So in this section, let's have some fun with Taylor series. In the preceding section, we saw that a power series represents a function on its interval of convergence. And this section explored the opposite questions. Given a function, what is its power series representation? We have already made a significant progress in answering this question because we know how Taylor polynomials are used to approximate function. So we now extend Taylor polynomial to produce power series called Taylor series. So definition, suppose the function f has derivatives of all orders on an interval centered at the point A. The Taylor series for f centered at A is f of A plus f prime of A times x minus A plus second derivative of f of A divided by 2 factorial times x minus A squared plus the third derivative of f of A divided by 3 factorial times x minus A to the power of 3 plus and so on, which will give us the sum from k is equal to 0 to infinity f of the kth derivative of A divided by k factorial times x minus A to the power of k. And do not forget, we call this part ck, which is c sub k, which is what? The kth derivative of f of A divided by k factorial, right? And a Taylor series centered at 0 is called a Maclaurin series. So let's start with the first example. We have find the Maclaurin series, which is the Taylor series centered at 0 for f of x is equal to cosine x, and then find the interval of convergence. So again, we are familiar with these problems, so solutions. So since we have a Maclaurin series, we know the center is at x is equal to 0. So which means my c sub k will just be what? The derivative of f of 0 divided by k factorial, right? And the sum also that we'll be looking for is what? The sum from k is equal to 0 to infinity, c sub k times x to the power of k, because a is 0. Because a is equal to 0, right? So, of course, for k is equal to 0, 1, 2, 3, and so on. So now, let's go ahead and find my c sub k. So, we know f of x is what? Cosine x, right? So this implies what? F of 0 will be equal to 1. So that means c sub 0 will be what? 1 divided by 0 factorial, which is 1, right? So let me write 1 divided by 0 factorial, which is 1. And f prime of x is negative sine x, which means f prime of 0 will be 0. So my c sub 1, I want you to follow this pattern, okay? My c sub 1 will be what? 0 divided by 1 factorial, which is 0. And then the second derivative of f of x will be negative cosine of x. So which means the second derivative of f of 0 will be negative 1. So that means my C2 will be equal to -1 divided by 2 factorial, right? Because K is 2. And then the third derivative of f of x will be equal to sine x. So which means the third derivative of f of 0 will be 0. So we can see C3 also will be 0 divided by 3 factorial, which is 0. So let's go up to the fourth derivative. The fourth derivative of f of x will be cosine x, so which means the fourth derivative of f of 0 will be 1. So we can see C4 will be 1 divided by 4 factorial. So again, can you see for if you look for the odd orders like C1, C3, those are what, 0. So C5 will be 0, C7 will be 0, right? We only have value for the even. So that is why we will set, we can set, let me write this one down so you can read, because the odd order derivative are zeros, right? So my C sub k, I will we will have what, 1 minus 1 divided by, x divided by, or let me write my C sub k first. Then we will have our C sub k will be equal to -1 to the power of k divided by 2k factorial. Do you see it? That is why you can see the first term will be what? 1 minus x squared. Therefore, the Maclaurin series for f is 1 minus x squared divided by 2 factorial, because k is 2 here, right? Then plus x to the power of 4 divided by 4 factorial minus, you can see if I go next, it will be x to the power of 6 divided by 6 factorial plus, and so on, which is equal to the sum from k is equal to 0 to infinity, -1 to the power of k divided by 2k factorial times x to the power of 2k. Okay. So now let's check for convergence. Which test do you think is best to use this one? We have already used it, so we will apply what? The ratio test. So again, the ratio test said what? R is equal to the limit. These are my A sub k. So A sub k plus 1, which will be absolute value of that will be what? Negative 1 to the power of k plus 1, right? Times x to the power of 2 times k plus 1 divided by 2 times k plus 1 factorial divided by the absolute value of negative 1 to the power of k times x to the power of 2k divided by 2k factorial, right? Sorry, I have one more parenthesis here. So this is equals 2 times 2 times k plus 1 factorial. So it's like this. As k approaches to infinity. So we have to simplify. We know this one will give me the limit. Use your scratch paper because we have done this one so many times. So I know you should know how to simplify this one. If you have a fraction divided by a fraction, you take the numerator. So what I will do is I will have negative 1 to the power of k plus 1, right? Divided by negative 1 to the power of k times x to the power of 2k plus 1 divided by x to the power of 2k times, so I'm just dividing like terms as I have 2k factorial divided by 2 times k plus 1 factorial as k approaches to 0. So if I simplify everything, you can see since it's absolute value, this does not matter, right? Even though it will become a negative 1 if I simplify, but because of the absolute value, it would still be positive. And x to the power of 2k plus 1 divided by x to the power of 2k, it will left what? The limit will have x squared. And take a scratch paper, you can see if I simplify this one, what will be left is what? 2k plus 2 times 2k plus 1 as k approaches to 0. And this limit is what? 0. Okay? And what does that mean? This means the series, this series converge, right? Because of what? In this case, r is equal to 0. So r is equal to 0, which is less than 1. for all x. So the Maclaurin series converges absolutely for all x, right? Which imply by the absolute convergence theorem that the series converge for all x. And the interval of, since it's for all x, the interval of conversion will be what? All real numbers, right? The interval of convergence is all real number. Okay, let's move to the next example, which we have. We are asked find the Taylor series for f of x is equal to 1 divided by 1 minus x centered at a is equal to 5, and then determine its radius and interval of convergence. So we proceed again, the same thing. In this case, my C sub k will be what? My C sub k will be the kth derivative of f of 5 divided by k factorial, right? So we already know f of x is what? 1 divided by 1 minus x, which means f of 5 will be equal to negative 1 divided by 4. Again, it's important to follow all the time this pattern, right? So that means my C0 will be what? Negative 1 over 4 divided by 0 factorial, which will be negative 1 divided by 4, right? So again, f prime of x will give me what? My f prime of x will give me 1 divided by 1 minus x square, which means f prime of 5 will give me what? This is square. So it will be 1 minus 5, which is negative 4, but square will make it positive, right? So it will be 1 divided by 4 square, which means my C1 will be 1 divided by 4 square divided by 1 factorial, which is 1 divided by 4 square, right? Or if you want, even if you want, let me write so you can see. So which is negative 1 divided by 4. 1 factorial, which is 1 divided by 4 square. So the second derivative of f of x will be 2 divided by 1 minus x to the power of 3, which imply the second derivative of f of 5 will be negative 2 divided by 4 to the power of 3. So you will see what will happen here. So my C2 will be what? Negative 2 divided by 4 to the power of 3 divided by 2 factorial. You can see 2 and 2 will cancel out. So which will make what? This one will be negative 1 divided by 4 to the power of 3. You see? So let me go and do 2 more derivatives. The third derivative of f of x will be what? It will be 3 times 2 divided by 1 minus x to the power of 4. And then the third derivative of f of 5 will be 3 times 2 divided by 4 to the power of 4. From there, we can see our C3 will be 3 times 2 divided by 4 to the power of 4 over what? 3 factorial. Or 3 factorial and 3 times 2 will cancel out. So which will give me what? 1 divided by 4 to the power of 4. I will do a last one so you will see exactly what is happening. So the fourth derivative of f of x will be what? It will be 4 times 3 times 2 divided by 1 minus x to the power of 5, which means the fourth derivative of f of 5 would be 4 times 3 times 2 divided by negative, right? Because this is odd, so we'll have a negative here. Divide by 4 to the power of 5. And then from there, we will see our C4 will be what? Negative 4 times 3 times 2 divided by 4 to the power of 5 over 4 factorial. So which will be what? Negative 1 divided by 4 to the power of 5. So did you follow this pattern? And then once you do that, you will see basically our C sub k will be, so our C sub k, which is the kth derivative of f of 5 divided by k factorial, will be equal to what? You can see from here, what do we see? We can see the sign is switching, right? From negative to negative and so on. So we already know what that will happen. But what we have here, the denominator, all of them is 4. But C0 is 4 to the power of what? 1. and C1 is 4 to the power of 2. So that's why, again, my C sub K will be negative 1 to the power of K plus 1 divided by 4 to the power of K plus 1. Okay, for K is what? 0, 1, 2, 3, and so on. And then we'll write and the series for F center at A is equal to 5 is the sum from K is equal to 0 from K is equal to 0 to infinity negative 1 to the power of K plus 1 times X minus 5 to the power of K, right? Divide by 4 to the power of K plus 1, which will be what? Negative 1 divided by 4. K is 0 plus X minus 5 divided by 4 square minus X minus 5 square divided by 4 to the power of 3 plus X minus 5 cubed divided by 4 to the power of 4 minus and so on. And now to determine the interval of convergence for this series, we apply again the ratio test. Okay? So again, sorry, I'm pressing my hand. Interval of convergence. We are going to apply the ratio test. So R will be equal to what? The limit of absolute value of A sub K plus 1 divided by A sub K, right? As K approaches to infinity, which will be equal to the limit of absolute value of K plus 1 will be negative 1 to the power of K plus 2 times X minus 5 to the power of K plus 1 divided by 4 to the power of K plus 2. Divide by A sub K, which is negative 1 to the power of K plus 1 times X minus 5 to the power of K divided by 4 to the power of K plus 1. So again, if I don't show you how this simplification is done, I believe by now you can practice this, right? So I'm just going to put simplify, sorry, for K approaches to infinity. So simplify, and then you will get what? You will get the limit. At the end, we will get absolute value of x minus 5 divided by 4 as k approaches to infinity, which is equal to absolute value of x minus 5 divided by 4, right? So then we will discuss when the series converge, as we know. So the series converge absolutely when R, which is what? Absolute value of x minus 5 divided by 4 is less than 1. Then we know how to solve this. You know how to solve this inequality. So we will solve the inequality. We know absolute value of x minus 5 divided by 4 is less than 1. This means what? You multiply both sides by 4, so that means absolute value of x minus 5 has to be less than 4, which means negative 4 is less than x minus 5, and x is less than 4. You add 5 on both sides. 1 is less than x is less than 9. So that means the series converge in between these two, right? And then we have to check the endpoint like we used to do as well. So converge is absolutely so the series converge absolutely in one between 1 to 9, right? And the radius of convergence is what? 4. So we can check if the series, just a quick check, okay? We can see the series diverge when you can do that yourself to check this one. Do a quick check. The series diverge at x is equal to 1. So I gave you the answer, but I want you to practice that at x is equal to 1 and x is equal to 9. Okay? So now let's do our next example, which is find the first four non-zero term of the Taylor series for f of x is equal to cube root of x centered at 8. So again, solutions. We know, notice that f has the derivative of all order at x is equal to 8. The Taylor series centered at 8 has the form, the sum k star from 0 to infinity, c sub k x minus 8 to the power of k. Of course, where my c sub k is what? the kth derivative of f of 8 divided by k factorial. This is the form, right? Okay, or let me write the first, the title center at a center at 8 as the form, right? So now our f of x is what? Cube root of x, right? So we have to find our c sub k. So f of x is x to the power of 1/3, right? Which means f of 8 will be what? 2. And that also means my c sub 0 will be 2 divided by 0 factorial, which is 2. F prime of x is 1/3 x to the power of negative 2/3, which means f prime of 8 will be 1 over 12. And then c1 will be 1 over 12 divided by 1 factorial, which is 1 over 12. And then the second derivative of f of x will be negative 2 divided by 9 x to the power of negative 5 over 3, which means second derivative of f of 8 will be negative 1 divided by 144, right? And that means my C2 will be negative 1 divided by 144 divided by 2 factorial. So which means C2 will be 1 divided by 2 factorial negative times negative 1 over 144, right? And then I will do the third one so you can see the pattern. The third derivative of f of x will be 10 divided by 27 x to the power of negative 8 divided by 3, which means the third derivative of f of 8 will be 5 divided by 3656. So that means my C3 will be equal to 5 divided by 3656 divided by 3 factorial, which will be 1 over 3 factorial times 5 over 3656, right? So then now we now have the power series. The first term is what? 2 plus the second term is 1 over 12 times x minus 8 plus 1 divided by 2 factorial times negative 1 divided by 144 times x minus 8 square plus 1 divided by 3 factorial times 5 over 36 56 times x minus 8 to the power of 3 plus, and so on. So if you do look at, we will have positive, negative, positive, right? So which will be equal to what? 2. Okay, let me write this one down a little bit. So this one will be equal to 2 plus 1 over 12 times x minus 8 minus 2 factorial is 2 times 1. 2 times 144 is 288 x minus 8 square. And then use your calculator. 3 factorial is 6. 6 times 36, 56 will be 5 divided by 20,736 x minus 8 to the power of 3, and then plus, so on. That's it. So now we have this question. Let f of x be equal to e to the power of x. A, find a Maclaurin series for f. You know, question A is easy to do, right? We have done something similar with A. Let me bring even this one down. We have done something similar with A already. So to answer question A, again, it said Maclaurin series. So we know the Maclaurin series will have the form sum from k is equal to 0 to infinity c sub k times x to the power of k, where c sub k is equal to the kth root of 0 divided by k factorial, right? So we'll see. We can just go ahead and write out this one, but I'm going to go, since f of x is e to the power of x, so we know all the derivative would still be what? E to the power of x. So we'll always have the same thing except the k factorial. So f of 0 is what? 1. So that means c0 is equal to 1. F prime of x is e to the power of x. So that means f prime of 0 would be 1, which also means c1, which would be 1 divided by 1 factorial, would also be 1. That's the second derivative, because we can see the second derivative of f of x would still be e to the power of x, and the second derivative of f of 0 would be 1, but my c2 would be what? 1 divided by 2 factorial. So now the Maclaurin series, so we'll say the Maclaurin series for e to the power of x is what? Is 1 plus x divided by 1 factorial plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus and so on, and the sum will be the sum from k is equal to 0 to infinity x to the power of k divided by k factorial. That's it. And now, if I'm asked to find its interval of convergence, so to find its interval of convergence, we would use what? The ratio test. So by the ratio test, R will be equal to the limit of absolute value of a sub k plus 1, which will be what? X to the power of k plus 1 divided by k plus 1 factorial over a sub k, which is x to the power of k divided by k factorial as k approaches to infinity. And we know this one will give me the limit of x divided by k plus 1, absolute value, of course, as k approaches to infinity, which is equal to 0. So because r is equal to 0, which is less than 1, for all x, the interval of convergence is from negative infinity to positive infinity. And C, we are asked use Maclaurin series for e to the power of x to find the Maclaurin series for the function x to the power of 4 times e to the power of x, e to the power of negative 2x, and e to the power of x squared. So I think we have done this one with the power series, right? So we can see, so x, I'm going to do first thing for x to the power of 4 times e to the power of x. So that will be equal to what? X to the power of 4 times the sum from k is equal to 0 to infinity, x to the power of k divided by k factorial, which is x to the power of 4 times 1 plus x divided by 1 factorial plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus and so on, right? Which will give us what? X to the power of 4 plus x to the power of 5 divided by 1 factorial plus x to the power of 6 divided by 2 factorial plus x to the power of 7 divided by 3 factorial, right? And for e to the power of negative 2x, we replace x with negative 2x, right? So if we do that, and so let me try to think, okay, good job. So if we do that, we'll have what? The sum from k is equal to 0 to infinity, negative 2x to the power of k divided by k factorial, which would be what? So the negative, you can take that, that would be the sum from k is equal to 0 to infinity, negative 1 to the power of k times 2x to the power of k divided by k factorial, which would be, if k is 0, we have 1. If k is 1, we have negative 2x. If k is 2, we have, hold on, let me see. If k is 1, so if k is 2, we will have 4 divided by 2 factorial, right? Okay, let me write. So if k is 2, we'll have 2x squared divided by 2 factorial. If k is 3, we'll have negative 2x to the power of 3 divided by 3 factorial. And if k is 4, we'll have plus and so on, right? So you can simplify this one, which would be 1 minus 2x plus 2x squared minus 4 divided by 3x cubed plus and so on. Okay, and then for e to the power of negative x squared, we replace x with negative x squared. So, same thing. I'm not going to waste too much time. So the sum from k is equal to 0 to infinity, right? Negative x squared to the power of k divided by k factorial, which will be the sum from k is equal to 0 to infinity, negative 1 to the power of k times x to the power of 2k divided by k factorial. Follow same thing. If k is 0, we have 1. If k is 1 minus x squared, right? If k is 2 plus x to the power of 4 divided by 2 factorial minus x to the power of 6 divided by 3 factorial plus and so on. Okay, that's it for this example. So now let's talk about the binomial coefficient. Definition: for real number p and integers k greater than or equal to 1, we have p choose k is equal to p times p minus 1 times p minus 2 up to times p minus k plus 1 divided by k factorial. And p choose 0 is always equal to 1. So again, let me write this one. P choose k, okay? That's how you read it, P choose k. So the first theorem that we have, again, I can give you some example about the binomial coefficient, but I believe you have already done some of them. So let's go to the theorem because this is taking a little bit of the time. So theorem of binomial series. For real numbers p different from 0, the Taylor series for f of x is equal to 1 plus x to the power of p, centered at 0, is the binomial series. The sum from k is equal to 0 to infinity. P choose k times x to the power of k, which is equal to 1 plus the sum from k start from 1 to infinity, p times p minus 1 times p minus 2, up to times p minus k plus 1, divided by k factorial times x to the power of k. And that will give us equal to 1 plus px plus p times p minus 1 divided by 2 factorial times x squared plus p times p minus 1 times p minus 2 divided by 3 factorial times x cubed plus and so on. And the series converges for absolute value of x less than 1 and possibly at the end point depending on p. If p is a non-negative integer, the series terminates and results in a polynomial of degree p. So let's go and do the first example of this. Consider the function f of x is equal to 1 square root of 1 plus x. A, find the first four term of the binomial series for f centered at 0. So that's my first question. So now let's use the formula, okay? Again, in this case, p is what? P is equal to 1/2. And to compute the first four term, so we have C0 is equal to 1, C1 is equal to 1/2 to 1, which will be equal to what? 1/2 divided by 1 factorial, and that will give me 1/2. C2 is equal to choose 1/2 choose 2, right? Which will be what? 1/2 times 1/2 minus 1 divided by 2 factorial, which would be -1/8. And then, so I'm using the formula, don't forget. C3 will be 1/2 choose 3, which will be 1/2 times 1/2 minus 1 times 1/2 minus 2 divided by 3 factorial, which would be equal to 1/16. Again, so let's not forget, we know P choose K, the formula. That's what I'm using to all of this, okay? So I'm using P choose K, which is my C sub K. All right? We said that is equal to what? P times P minus 1 times P minus 2 up to what? P minus K plus 1. So divide by K factorial. So if K is 0, we stop at P and so on. Okay. So now we can write the term, right? So the leading terms of the binomial series are 1 first, C0 is 1, plus 1/2 times what? X minus 1/8 times x squared plus 1/16 times x cubed minus and so on. And then we are asked to approximate 1.15 to 3 decimal places, assuming the series of for f converges to f on its interval of convergence, which is close interval -1, 1. So to use this approximation, so we know since the beginning f of x is what? Square root of 1 plus x, right? So the Taylor polynomial P sub n, which we find here, this is my P sub n, can be used to approximate because 1.15, so which means x will be equal to 0.15, right? Why? Because f of 0.15 will be equal to square root of 1.15. So the Taylor polynomial from part A can be used to approximate f of 0.15. Again, I will make my table. Again, n Do not forget, okay, if n is 0, p of 1 is what? 1. You can put 1.0. If n is 1, p of 1 is 1 plus 1. So let's not forget where we are substituting, okay? I'm going to help you here. P sub 0 is equal to 1. P sub 1 is 1 plus 1 half x. P sub 2 is 1 plus 1 half x minus 1 over 8x squared. And P sub 3 is everything we have there so far, plus 1 over 16 x cubed. So if n is 1, substitute 1, we have what? Sorry, I'm making a mistake again. Let me correct this one. No, there is no mistake. So it's 0.15, okay? So we'll have 1.075. And if n is 2, you substitute 0.15 on P2, we'll get 1.0721875. And finally, if n is 3, we'll get 1.07398,438. Okay. So we can see because the approximation with n is equal to 2 and n is equal to 3 agree to 3 decimal places, right? The difference of this one is 3 decimal places. So the approximation is, let me write that so you know why we stop here. Because summations with n is equal to 2 and n is equal to 3 agree to 3 decimal places. Why? The square root of 1.15 is also approximately 1.072. When rounded. So we can conclude what? 1.072 is the approximate. Okay. So now theorem convergence of Taylor series. Let F have derivatives of all orders on an open interval I containing A. The Taylor series for F centered at A converges to F for all x in I if and only if the limit of R sub n of x as n approaches to infinity is equal to 0 for all x in I, where R sub n of x is equal to what? F to the power of, the nth plus 1th derivative of c, f of c, divided by n plus 1 factorial times x minus a to the power of n plus 1. So r sub n, which is equal to x to the power of r sub n of x, which is equal to the n plus 1 derivative of f of c divided by n plus 1 factorial times x minus a to the power of n plus 1 is the remainder of at x with c between x and a. So let's do this example quick, the last one. Show that the Maclaurin series for f of x is equal to e to the power of x converges to f of x for negative infinity between x is between negative infinity to positive infinity. So we know, first of all, so from the previous example, so we know the Maclaurin series we already have done this one and proof for f of x is equal to e to the power of x is what? The sum from k is equal to 0 to infinity x to the power of k divided by k factorial, which is what? 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus and so on up to plus x to the power of n divided by n factorial, right? So we have done this one in the previous example. So now we know this also converge, we have proof which converges for negative infinity less than x less than infinity. So we have proved this one in the previous sections, right? I don't know which example, but we have already proved this one, so I'm not gonna do that. So it was shown that the remainder is what? R sub n to the power of x would be equal to e to the power of c divided by n plus 1 factorial times x to the power of n plus 1. So we are not asked to find the remainder, so I will just stop right here. And then below you have a table about some common Taylor series that is used. So you can read this one, okay? You can pause the video, take note about this one, and that's it. I will see you in the next section.